Hello, Algebra 1. Today I'm going to be going over section 3.3, function notation. You will find this on page 71 of your student journal. So function notation is a vocabulary word in this section, and it is described as equations that represent functions are often written in function notation. So I'm going to show you what that looks like. So function notation. So function notation, the way that looks is we use the notation, and you may have seen this before, maybe not, but it looks like this with an F and then parenthesis, and there's an X inside of it. Okay, the way that we read that is we read it as f of x. So it's a function containing the variable x. Okay, so that's how we read it. And then just so you realize that this notation where you see the parenthesis, this is not multiplication. It's not what that means. You might look at it and think f times x, but that's not what it's saying. This is a specific function notation of f of x. They can also use other letters, like you might see g of x, h of x. If the function has a t instead of an x, they might call it f of t. So there's different letters that they can use using function notation. Okay, so looking and comparing it to something that we already know, if you had an equation like y equals 4x minus 1, what they can do with that to note that it is a function, which if you were to graph this in Desmos, you would see it's a line, and it would be a diagonal line, making it a function, meaning I could write it using function notation. Now, where function notation comes into play is it takes the place of the y. So I could write this instead as f of x equals 4x minus 1, and vice versa. You could write it going either way. So these two equations mean exactly the same thing. They would graph exactly the same line, okay? So just a couple other notes. F of x is going to be the output value of which is I didn't mean to put that. F of x is going to be your output value, just like y is considered the output value, and the x is going to be considered still the input value when it comes to function notation. Okay. So how can we compare this to something like we know as an ordered pair? Comparing it to an ordered pair, okay, we would, if we think of like an ordered pair, just to pick something, I don't know, 2, negative 1. Okay, so one thing that that we know is that an ordered pair is x comma y, but when it comes to function notation, instead of a y, we have an f of x. So it could be written as x comma f of x. So one thing that we're going to be talking about today is the idea that because of all of this, we know that saying y or f of x is exactly the same thing. So f of x as a whole entire value is the same as saying y. Okay, so we're going to, so another way that I could rewrite this ordered pair is I could rewrite it where I say f of my x value, which is 2, will equal my y value, which is -1. So by saying f of 2 equals -1, I know that this value inside of here is my x. This value that this whole entire function notation equals is representing my output value. So if I put x into the function, what's going to come out of that whole function is going to be -1. Hence the names input and output value. So this is basically another way to write an ordered pair. And I'm going to talk about that as well a little bit further into our examples. Okay, so one of the things that we're going to be doing is we're going to be evaluating functions. Okay, so let's look at this first graphically. Now, you don't have these two examples in your student journal, so please just follow along. So let's look at this on a graph, okay? I'm not going to do both of these problems. I'm just going to do one of them. So evaluating a given a graph. So the idea of evaluating, when you evaluate something, it means to find the value of. So your answer is going to literally be a number. So we're going to figure out if I put certain x value into a function, what is my output value or my y? Okay. So in part A here, they say f of -3, and they're wanting you to figure out what it equals. This value of -3 is representing an x value. So what I'm going to do in my graph is I'm going to look where my graph hits the x value of -3. So my x value of -1, -2, -3 is right here. I'm going to go along until I get to a point where I have an x value of -3. So this point right here is the point -3, 2. So that means when I input a -3, what I get out of it is the y value of 2. So the value of f of -3 is 2. That is your answer. It's 2. So let's do f of 0. Here you're looking for an x value of 0. That's this point right here. So for that ordered pair, that is the ordered pair 0, 1, 2, 3, 4, 5. So that means what the value of f of 0, meaning when x is 0, is going to output or give me the y value of 5. Okay, so you're going to get more practice with these in your homework that you'll do after watching this video. So that was when you are given a graph. You will not always be given a graph. Okay, so let's look at another example. So in your student journal, you actually have these problems. So let's go to number 3 on page 71. So I'm now on page 71. I like number 3 because instead of saying f of x, they're using h of x. And then if you look at these others, they use s of x, t of x, u of x. And they do that because oftentimes within one problem, you could potentially have more than one function. So we need to be able to distinguish between each of the functions or equations that are given to us. So that's why they just kind of practice that in each of these problems. But don't think of the problem any different than you would before. So here they're saying evaluate the function when x equals -4, 0, and 2. We're just going to do the when x is -4, just for the sake of time. Okay. So when they're saying evaluate the function, again, find the value of the function. Okay. When your x equals -4. So instead of having h of x, we are going to figure out what does h of -4 equal. Well, if you've noticed, what I did is I made -4 take the place of x. So if I input a value of -4 for x, what am I going to get out of it? Well, the way you're going to figure out what goes out of it is you're going to substitute the x value of -4 for x. So when I go ahead and do that, I'm going to simplify this other side. Remember, this does not mean h times -4. This represents one whole value, so it sticks together. Don't separate it. The only thing I'm going to be dealing with is the other side. I'm going to go ahead and simplify that using my order of operations. I know that I need to multiply first. -2 times -4 is +8. And then I get 7 plus 8, telling me that h of -4 equals 15. Okay, so what does that value mean? Okay, so if I go to, let's go to Desmos, and you can do this along with me on Desmos. If I go to the graphing calculator and I type in that function they gave me, okay, it'd be h of x, whoops, equals, what was it, 2? No, it was 7 minus 2x. There's that line. Okay, and we found h of -4. So let's find, here's -4. Go along the line, and if you look, it's kind of hard to get it exactly, but if you look at -4, what is the y value? It's 15. And isn't that what we got as our answer? Right? So there's the ordered pair -4, 15. So basically what this is telling me is it's telling me that on the graph of this function here, you are going to find the ordered pair -4, 15 on that line. So -4, 15 will be a point on that line. Okay, or on this graph or on this line, which the graph happens to be a line. Okay, so that's basically what you are doing there. Okay, and we could very easily find the other values, 0 and 2, their output values by plugging each one of those in. But again, for sake of time, I was just doing that. All right. So that's what happens when they give you the x value. So here for these problems, they gave you the x value. Okay, so you were given the x value, or what we can call the input value. Okay, now they are going to change that up on these problems down here. Okay, so let's take a look here at, let's do number 11. Okay, number 11, they write their function using w of x equals 5, 6x minus 3. What's different about these problems is in the directions it says find the value of x so that the function has the given value. Okay, well, what does that mean? Just think about it as this. I want to find the value of x. So my goal here is to figure out what does x equal. Okay, so at the end of the problem, I should have x equals some number value. Okay, and we can use Desmos to check our answer as well. What's given to us is different. Notice they didn't give you x. That's not what we're trying to find. Okay, that's what we're trying to find is x. So of course they're not going to give it to you. So we have this. This is our given information. What they have given us is they've given us the value of w of x. They've given us the output value. So that means that this 18, this value here, is going to take the place of w of x, this whole entire thing. Because remember, that represents one value, the output value. So in these problems, you are given the output value, or what we can think of as the y value. Okay, so I'm going to go ahead and I'm going to plug in -18 equals, and keep everything else the same, just like that. Okay, so going ahead, remember, we're trying to find the value of x, so I want to solve for x. So I'm going to go ahead and solve for x by adding 3 on both sides. That's going to give me what? -15, whoopsies, equals 5, 6x. Okay. Now we need to get this fraction to the other side. We've talked about this before, the way that you get rid or cancel out, I should say, a fraction. is to multiply by the reciprocal. So I'm going to multiply by the reciprocal, multiply by the reciprocal. Just think of negative 15 as negative 15 over 1. You can multiply straight across and then divide, but you can definitely simplify the 5 and the 15 by 5. 5 goes into 5 once. 5 goes into negative 15, negative 3 times, right? Okay, so then I'm going to go ahead and this cancels, all this cancels out. And you are left with x equals, oh, look at that. You're left with x equals negative 18. So let's go ahead and check our answer using Desmos. I'm going to go back to Desmos. I'm going to undo this one here. I'm going to do w of x equals 5/6, right arrow, x. I believe it was what, minus 3. Okay, so I'm going to go to a y value of negative 18. So I'm going to go to a y value of negative 18. I'm going to go down to where that is. There it is. Negative 18 is a point on that line, so I know I'm correct. So if the y value is negative 18, the x value actually happens to also be negative 18. That doesn't always happen, but there you go. So we have 3 different types of examples. One where you have a graph, one where you're given the input value or the x value, one where you're given the output value. We can also think of it as the y value. You will see each of those types of examples in your homework tonight. Okay, so I hope that this video helps you with your practice. Please come to support if you need more help.